Good morning and thank you for coming to our ME412 final project competition. We are Team The Air Splits. My name is Amanda Boyd and my team members are Ben DeWise and Craig Miller. The objective of our project was to design, analyze, build, and test a Ranque Vortex tube. A Vortex tube works by injecting compressed air into a Vortex chamber. The air then moves down the tube in a helical motion and, as it does, it allows hot air to escape from one end of the tube and cold air to escape from the other. We had to maximize the temperature difference between the hot and cold ends, create an accurate mathematical model of the vortex tube, all while minimizing cost.
The control volume model for the vortex tube is shown on the screen. The inlet provides compressed air at 100 psi. Thermodynamic laws state that the energy in must equal the energy out. Calculations were performed using a cold end mass fraction of 44%, and the math model predicted a cold end temperature of negative 2.55 degrees Celsius, a hot end temperature of 32.4 degrees Celsius, and a temperature difference of 34.9 degrees Celsius, or about 95 degrees Fahrenheit.
Shown on the screen is the model of our first prototype. We constructed the vortex chamber out of a single block with two input holes offset from each other. The input hole diameter was too large to allow the air to properly vortex through the tube, so there was no temperature difference. The second prototype had a vortex chamber designed out of PVC fittings. 8 small holes were drilled tangential to the vortex tube to allow the air to enter the tube in a helical pattern. Additionally, a longer tube was used and a conical aluminum piece was placed at the hot end to act as a control valve. The control valve is there to allow the hot air to escape around the edges of the cone and force the cold air back down the tube to the other end, where there is a small outlet hole.
During testing, the prototype produced an average temperature difference of 34.7 degrees Celsius, which was a 0.71% error from the mathematical model. The prototype cost $10 to build and was a functional design.
I'm Ben DeWise, and I approve this message.